And don't forget, GTC is next week, where you can get a spark of imagination or creativity. Check out the details on the Level 1 forums, and maybe catch up with me, say hi, and check out the sessions, do whatever. If you're going to attend, you can use the link. If you're going to watch online, you can use the link and sign up, and who knows, maybe you'll get a spark of excitement looking at all the stuff that's possible and you can run. You can build your own OpenClaw. I don't know. Behind me, there are 4 machines running games in parallel, and the idea here is to automatically debug games. It's level 1. We always do unhinged things, right? 4 Linux machines automatically playing games, debugging things. That's the idea. That's where we're headed. That's our future. Some of you are so sour. I would say this is the lemonade that we're making from the lemons that you think are lemons, but I think are something. Let's talk about what we're doing here, because it's actually kind of exciting. So these are 4 gaming machines with a different configuration. I've got one machine that has an Nvidia GeForce GPU, and then the other one is a Strix Halo. That's our GMK Tech mini PC. Don't worry about the Dell Pro Max with GB10. That's not hooked up, we're not using that. This is an AM5 system that's based around the 7600X, and this is an older system that is based on the Titan X. So this is another Nvidia GPU, but this is an older Nvidia GPU, so it doesn't count because Nvidia's abandoned the drivers for the older Nvidia GPU. Each one of those has a SiPed Nano KVM hooked up to it. And the games are being played not locally, but remotely via that KVM. You see, that device takes the HDMI signal from the video card and puts it on the network. A few of you immediately jumped to, can this play StarCraft? What's the actions per minute? And yes, it can play StarCraft. And yes, there are some pretty serious actions per minute. Now, the Nano KVM is not capable of that, but you could play StarCraft over the network through the connection. But because it's over the network and because it's doing video capture and all that sort of stuff, we can turn something loose with that. Benchmarking your favorite game, that's pretty straightforward. You could automate that. You could have something like auto hotkey, load a level, do something like that, do the capture, generate some performance metrics. But what if things look weird? What if the textures change? Linus Tech Tips, I think he's cursed. They're doing the Linux challenge, and he showed Bazite where just the lower left-hand corner of the desktop was flashing. It's hard to catch those kinds of failures with automated testing. But this as a platform for automated testing, this would catch that. Why? How is it able to do that? Because in the automated testing, it can capture video snippets, boot up, moving around the desktop, launching a game, playing a game, and save those snippets and organize them for a human operator to be able to look at and say, oh, this is clearly something has gone wrong here. Something is not right. And so as a test platform, putting this together, it has become surprisingly easy to orchestrate these kinds of things. Now, to be sure, this is actually an insane amount of work. One of the pieces that does this kind of orchestration is called Turnstone. And this is an AI orchestration platform. How it works is kind of like a more enterprise version of OpenClaw. See, OpenClaw, you just let the AI agent loose to do anything. But when we're talking about this, when we're talking about benchmarking and that sort of stuff, you could use something like auto hotkey to automate windows, like moving the key around or loading the level or waiting for something to show up on screen, moving the cursor, clicking load. You've got some automation there. But if you had a model that understood and recognized playing video games, and you could turn that loose, then you could have a model that launches the game and another model that is like, okay, I don't know how to play a video game, now you play a video game. And so you end up building this little suite of small agents to do things instead of one giant monolithic agent that could just lie to you and tell you that, it played a game when it didn't actually play a game. And so this, as an orchestration platform, we can start to glue the little pieces together. But then the challenge becomes, how do you remotely control a machine? Well, that's a piece of hardware. It's a SiPed Nano KVM. It's able to capture 1080p 60. And with 1080p 60, you can use a hardware scaler from 4K to 1080p. Like, that's a whole other conversation. But with 1080p 60, it's able to do hardware capture, and it's able to send keystrokes, mouse and keyboard movements, back to the host computer. Incidentally, this is why anti-cheat is so dumb, because if somebody wants to cheat with something for auto aim or whatever, you could build tools around this. I'm sure people are already building tools like this for that. But for me, I would like to do something that helps automatically debug hardware issues or graphical issues or issues that you don't necessarily see when you're using automated tools that are not connected to real hardware. You could run game capture and do local capture, but would you see a flickering desktop? Not necessarily. If it's a problem with the double buffering or something like that, you might not see that unless you're actually using a physical display. So doing that kind of test harness can be harder. I think also because there's so many disparate systems for those kind of test harnesses, it is much harder to do that kind of end-to-end testing in a pure software virtual machine, accelerated environment versus just, I can plug one of these in, capture it, and store it automatically for human review as well as automated review. So the componentry here, Turnstone AI agents that I've been sort of, a little bit of this is smoke and mirrors and a little bit of this is actual AI agents doing things. But Turnstone is legit. This is that is an amazing platform for doing this kind of thing and then plugging into it. It's like creative uses of what you can do here. And then the Nano KVM for giving me control. Now, the other part of this that kind of inspired this idea was NVIDIA's video search and summarization service, VSS. If you didn't see the video that we did on VSS, you should check that out. VSS 3 is just launching. They've revamped the web UI, but this is a toy application. This is meant to be an explainer for the kinds of things that are possible. And for my use case, what I'm doing here, where I'm capturing a bunch of video game snippets with a bunch of different video games, or asking an agent to play a video game for 10 or 15 minutes, and then capturing the video with that, it's nice to have something to be able to review that. All right, one of the big components here is the example project from Nvidia, their video search and summarization service. And they've made a lot of changes with version 3. We've done videos about this in the past. If you missed that, this was a complete orchestration of a bunch of AI agents in a trench coat where they could take video, like say surveillance video of a warehouse, and then report if the employees had done anything unsafe, like not wear professional protective equipment or anything like that. It didn't require a specialized training model. You could just run it as you are. And that by itself, I think, is disruptive to a huge number of products in exactly that category. But it could also do traffic analysis and all that sort of stuff. Well, for VSS 3, I wanted to actually try to plug it into something, hence the video game thing. But you have to understand the part that Nvidia provides you and how to interface with that. And so here is the architecture overview for how that works. And what they've added for VSS 3 also includes things like real-time alerting, so that you can get an alert at the time that some event happens. And they've also done some performance analysis and some sizing so that you know about what sort of performance you can expect from, like a B200 system or a system like ours where we've got multiple Blackwell RTX 6000s or other different configurations. And this does take a lot of horsepower to run. I think minimum is 2 RTX Pro 6000s, but my 4 RTX Pro 6000 setup here struggled a little bit by the time I got done bolting on all kinds of other inefficient stuff and trying to deal with a whole bunch of different streams at once. But that is purely on me. That is purely on the lack of optimization on my part. So they give you, a smart city blueprint and a public safety blueprint and a warehouse blueprint. And this is really 90% of the stuff that you need. If you understand this and you can orchestrate this kind of thing, you can get a job building these kinds of things tomorrow. This is one of the few sectors that is growing and adding a lot of employment, be that as it may. Again, lemon's lemonade. Hang on here, because we're building something that I think is good for open source and development. It's fill in some gaps here. There's chat where you can drag and ask a file. There's also video management, and so you can see some of the files that, you can programmatically submit these. You can modify this in a bunch of different ways because it's all open. There's different game files where we can, ask it questions or do whatever. But the use case here, but the use case that I was showing you is sort of non-interactively. It's how do we deal with this non-interactively? And that is Turnstone. So Turnstone is another project. It's multi-node AI orchestration, but it is deterministic. Like all the worst sorts of things about AI where it can behave non-deterministically, this is AI for setting up scaffolding that is repeatable. And so like we can build a tool to help test and do this, and the part where like the AI is involved is minimized, and the part where the AI has to like think creatively also requires human approval. So we put a thing together that connects the APIs, and it looks at the video and it does the keystrokes, but a lot of that is not AI on the fly. It's AI to create a process, and then you can use AI to execute the process and get the results from the process, or AI to help execute the process, but it's never really human out of the loop, at least architecturally. And so this is kind of an enterprise version of the thinking in something like OpenClaw. But using Turnstone to build this is part of why Turnstone exists. And so we can look at the Turnstone window. Well, I've created an error with some of the agents, but for the 4 PyKVMs that we can have an agent running 1 per, gathering clips and then submitting clips to this thing. And so like in this reasoning trace here for this one, it's like we have a small clip of you know, Lara Croft running, and there's some video there. I've sort of manually did this to give you an example of like a driver glitch, because I was having trouble generating a driver glitch. And so, you know, it says stealth kill plus 30 XP, but there was some color there. And so it says strategic movement through wooden structures and foliage, plus 30 XP, that uses stealth. And so like it knows. This has not had any special fine tuning or anything like that. This is literally just the VSS model out of the box. If you look at the documentation for how this is put together and like how the containers exist, is like these are the Nvidia containers, and there's a lot going on here. It's like we have the replay stream and an agent and an envoy proxy and the UI agent. This is the thing that I'm connected to, but there's a whole bunch of little pieces here that are all sort of doing different things. And then on top of that, we have Turnstone, and Turnstone has an agent that is supervising other agents. Now you might have noticed in Shadow of the Tomb Raider, light transitions between natural and artificial sources. It didn't detect video glitching there, but it still was able to say, well, the light transitions between natural and artificial sources. One of the directives to the Turnstone agent was to, in the directory of videos, give it a score from 1 to 10, whereas 1 means that it's the #1 priority that a human should review it, and 10 is, human probably doesn't need to look at it. It seems like everything is working pretty well. And the score for this particular file ended up being a 4, which is, human probably should review it. But some of the other clips that we did, you know, those were like 7, 8, 9, 10. So this is just something that I was able to throw together for this video. This is not really real, but if somebody actually put some engineering work into this, and certainly this kind of a tool could be built to catch things like the desktop flickering on Bazzite because of a certain driver version or a certain VBIOS version or whatever that particular issue was, testing it on real hardware with end-to-end stuff. Now, another one of these clips had black screen cutouts, and the reason it had black screen cutouts is because I was using a crappy HDMI cable between the computer, but the AI was able to say, is like, well, during this gameplay there were black screen cutouts. So in other words, on the Turnstone side, I've got all these agents working and submitting, well, working to create clips with varying success. Now, some of those, you know, it's just auto hotkey, and some of those is like, okay, let's have Nitrogen actually like try to play the game and see how badly that goes. Sometimes Lara Croft is just gonna jump in place, and that's okay. And you know, sometimes the work streams will crash because, you know, it's held together with baling wire and duct tape. But it's generating clips that can then be programmatically submitted to VSS with a prompt like, analyze this for that kind of thing. Now, VSS is gonna need fine tuning to do this for video games. It actually works really a lot better for like the warehouse or traffic analysis or any of that kind of thing. But for video game stuff, it actually did work pretty well. Like, it seemed to recognize that it was looking at video game footage, which is hugely impressive. Now, the agent that was playing the game was Nitrogen, and I expected Nitrogen to work better than it did. It did not work well. This model, I mean, there's something about this model where it really only looks like at the last frame of every second, so it's like it's operating on like 1 FPS, and it wasn't great in Shadow of the Tomb Raider. But again, this is, you know, this is the Will Smith eating spaghetti badly phase of our existence here. And with some fine tuning and with some customization, we can probably get there.
But the reason I'm excited about this is not the AI part of the part that's doing the work here, it's the AI part of building the tooling and the scaffolding for regular scripts and that kind of thing. Because if we use AutoHotkey and we use the traditional stuff, yeah, you can get there, but it's like a 40 or 60 or 80 hour proposition. But with assistance, building that kind of a scaffolding that doesn't necessarily depend on AI once it's running, you're depending on AI to build the scaffolding and help you as a developer. It takes that thing that might take 150 hours and makes it more like 15 or 20 hours for this kind of a result. And so I'm trying to explain this in a way that is like, as a software development tool, being able to do software development that can look at a video and kind of tell you what's going on in a video with reasonably high fidelity, and then building something traditionally algorithmic around that from, you know, the computer science perspective, is not a thing that we've been able to do before up till now. And that we have those tools, you can build things like this, and there's really no excuse for Linux's usability to not improve 10 or 100-fold if we build tooling like this to help us catch bugs and to help us do automated testing to make sure that bit rot and other bugs don't creep in. That's why it's exciting to me.
So in my case, with this video game running in the background and, you know, sort of being a long capture, one of the things we can do is take that long clip that's recorded and ask the agent to summarize it. And so another agent will run and do that. Where is that running? That's running on our 4 GPU RTX Pro 6000 system. It actually takes a lot of horsepower to be able to run this locally. You can run it in the cloud, that's totally fine. But I think that for a lot of people, it's pretty attractive to be able to run this locally. Think about search and surveillance. Like if you were using this for security at your building, like your office security, and it's like, is there anybody working late? How is this working? It would be a lot better if that were, you know, sort of offline and privacy respecting and not in the cloud and not, you know, extra copies of the streams. Like, oh, Bob and Mary spent a lot of time at the office. That's weird, and that goes into some cloud database somewhere. I'm not really super enthused with that. But having this platform be open so that I can build things with it that I trust myself, I think is really good. As a platform for folks like you watching this video to be able to build a new product around the ecosystem here, it's pretty impressive. And notice the architecture. Like I talked about Turnstone and being a bunch of small agents working together to do things. That's also what Nvidia has done here between Cosmos Reason and the other models. And like, it's just a fleet of Docker containers operating on a particular data set. And this is going to be the tried and true system architecture of these sorts of tools moving forward from now until the end of time. So like, you can do a lot of really interesting stuff with video search and summarization. Right now, what I have, this is just a toy, but I would love to develop this further. Like if this could be of use to the Linux community, or you know, hardening drivers or making sure that drivers work more coherently and more cohesively, that's something that I would love to work on. That's something I would love to put a team together to be able to work on this kind of hardware and have more automation for that kind of platform. Because the bug that Linus encountered, it's one of those weird edge case bugs, but that doesn't mean that we can't build insane test harnesses around this in order to catch those kinds of bugs. And this is not something we would have been able to do easily, as inexpensively, without this technology 5 or 10 years ago. And so that aspect of it, for me, is really exciting. I'm Wendell, this is Level 1. This has been a look at some mad projects here. Is there something here? I don't know. Probably, maybe. But the fact that I could string this together with stuff that's out there, for me, was really inspiring. So, I don't know. If you're working on something like this, or you've done your own project with these, you know, show it off in the forums at Level 1. I like our community. I like what we're building. That's enough rambling for me for this one. I'm Wendell, this is Level 1. If you have any questions or I missed anything or you want to chat, hit me up in the forum. I'm signing out and I'll see you there.